What we observe is not nature itself, but nature exposed to our method of questioning. For Germany, the war was like an end game in chess, in which she possessed one castle less than her adversary. The loss of the war was as certain as the loss of an end game under these conditions. The problems of language here are really serious. We wish to speak in some way about the structure of the atoms, but we cannot speak about atoms in ordinary language. This proving of such and such I found to be almost like cheating. You start somewhere, and then you go into a dark tunnel, and then you come out at another place. You find that you have proved what you wanted to prove, but in the tunnel, you don't see anything. The German physicists knew at least so much about the manufacture and construction of atomic bombs that it was clear to them that the manufacture of bombs in Germany could not succeed during the war. For this reason, they were spared the moral decision whether they should make an atomic bomb, and they had only worked on the uranium engine. Natural science does not simply describe and explain nature, it is part of the interplay between nature and ourselves. In 1924, I became a docent in Göttingen and worked out the quantum mechanics during a holiday stay on Heligoland. Every word or concept, clear as it may seem to be, has only a limited range of applicability. The end of the First World War had thrown Germany's youth into great turmoil. The reins of power had fallen from the hands of a deeply disillusioned older generation, and the younger ones drew together in larger and smaller groups to blaze new paths, or, at least, to discover a new star to steer by. It is true that in quantum theory we cannot rely on strict causality, but by repeating the experiments many times we can finally derive from the observations statistical distributions, and by repeating such series of experiments we can arrive at objective statements concerning these distributions. I would say that I was absolutely convinced of the possibility of our making an uranium engine, but I never thought that we would make a bomb, and at the bottom of my heart I was really glad that it was to be an engine and not a bomb. The solution of the difficulty is that the two mental pictures, which experiment, lead us to form, the one of the particles, the other of the waves, are both incomplete and have only the validity of analogies, which are accurate only in limiting cases. After I had written a paper or letter for Bohr, I always had the impression that I had learned something which I could use for my own work. And somehow, I never felt that I had too little time for my own work. I always found time. The uncertainty principle refers to the degree of indeterminateness in the possible present knowledge of the simultaneous values of various quantities with which the quantum theory deals. It does not restrict, for example, the exactness of a position measurement alone, or a velocity measurement alone. The violent reaction on the recent development of modern physics can only be understood when one realizes that here the foundations of physics have started moving, and that this motion has caused the feeling that the ground would be cut from science. It is generally believed that our science is empirical and that we draw our concepts and our mathematical constructs from the empirical data. If this were the whole truth, we should, when entering into a new field, introduce only such quantities as can directly be observed and formulate natural laws only by means of these quantities. Thank you for watching. See you on the next video.